Hi, this is Andrew, and I'm Viki, and we are your lathe leads for the 2020-21 Gun Robotics Team season. Welcome to the second video of the Gun Robotics Team Lathe Training Series. Today, we will be showing you how to insert stock into both the collet and chuck lathes, how and when to change speeds, and how to properly adjust your tool height. Remember, before you receive any hands-on training, you will need to pass an online test covering this material. Before we get started though, make sure you're always following the safety rules of the shop. Wear your safety glasses at all times, always roll up your sleeves, tie back your hair, make sure your knees, midriff, and back are covered, make sure you're wearing closed-toed shoes, and also check the people around you.
As mentioned in the first video, the collet lathe uses collets. They only fit a certain diameter of stock. Fortunately, we have many sizes of collets. To use a collet, measure your stock diameter and then choose the correct collet by reading the collet size. The collet size can be seen on the face of the collet here. Here are the steps for inserting a collet and your stock material into the spindle. With the motor off, inspect the end, thread, and alignment slots of the collet to make sure that they are free from any metal chips or burrs. If not, clean them with a brush. Also, check and remove any chips inside the spindle. Insert the collet into the spindle here. Gently rotate the collet to match the alignment slot in the collet with the alignment pin in the spindle. With your right hand gently pressing the collet into the spindle, use your left hand to turn the knob on the tightening lever clockwise until it engages the thread on the collet. This should take a few rotations. Insert your stock into the collet. For all lathe operations, the appropriate length of stock sticking out of the collet depends on the material and the diameter of a stock, but a good rule of thumb for the collet lathe is not to leave more than 1/2 of the stock sticking out. Turn the knob clockwise until it starts to feel tight. Pushing the tightening lever with light to medium pressure. If you have over-tightened the knob, you will need more than medium pressure to close the lever, so back up and readjust the knob. Under-tightening the stock can come flying out and potentially injure someone. Over-tightened stock can damage the collet. Here, there is some normal rattle in the lever, even when it's correctly tightened.
The chuck lathe is more versatile than the collet lathe since it can hold on to a wide range of diameters, including very large diameters and diameters between collet sizes. Here are the steps for inserting your stock material into the chuck. First, inspect the chuck jaws and threads of the chuck to make sure they are free from any metal chips or burrs. If not, clean them with a brush. Step 2. Locate the square chuck key hole on the side of the chuck. Manually turn the chuck by hand if you cannot see it. Step 3. Insert the chuck key into the hole, turn clockwise to close the jaws, or counterclockwise to open them. Bring the opening between the jaws to a size a little bigger than the diameter of your stock. Place the stock in between your jaws and close the jaws, wiggling the stock as the jaws make contact with your stock until the stock is firmly and evenly held between all 3 jaws. Under-tightened stock can fly out and potentially cause injury when the motor is turned on, while over-tightened stock can ruin the finish or damage the jaw. Remove the chuck key and place it on the control box.
Both the collet lathe and the chuck lathe have a system of internal gears that can be adjusted to control the rotational speed. The proper speed for any lathe operation depends on the material and the diameter of your stock. For the typical stock used to machine GRT robots, The recommended speeds are approximately 700 RPM for aluminum, 400 RPM for steel, and 1000 RPM for plastics. For larger diameter stocks, the speed must be reduced. Before adjusting the speed on either lathe, first stop the machine and make sure the outer surface of the chuck is free of any metal chips to avoid personal injury. Here are the steps for changing the speed on the caught lathe. Look at the chart at the front of the lathe to determine the speed gear combination required for the speed you need. On the caught lathe, the gear combination is represented by a letter and a number, which for aluminum is C1. First, adjust the letter knob and manually spin the chuck to make sure the gears are correctly meshed. For example, if the lathe is set at B2, first change to C2 by turning the knob. Then adjust the number lever behind the knob and manually spin the chuck to make sure the gears mesh correctly. Here are the steps for changing the speed on the chuck lathe. Look at the chart at the front of the lathe to determine the gear combination required for the speed you need. On the chuck lathe, the gear combination is represented by 3 letters, which for aluminum is JLM.
Right now it is at JKP, so we'll have to change. To get to JLM, we must change the second and third knobs. With the motor off, rotate each lever one at a time to move its arrow to the desired setting, while manually wiggling the chuck to help the gears mesh.
Lathe tools are held in place using a tool holder and a tool post. Each lathe is equipped with a quick change tool post to which tool holders are attached. To switch between tools, turn the tool post handle to unlock, remove the tool holder, clean the new tool holder and tool post with a brush to remove any metal chips or flakes, replace the new tool holder, lock the tool handle in the opposite direction. Each lathe has 3 tool holders that are correctly adjusted for that lathe, and they should not be interchanged with the other lathe's tool holders. Keep the 3 standard tool holders by their respective machines to avoid wasting time readjusting heights. If it takes a lot of force to cut through material, or if there is a nib left on a face after facing or parting, it is most likely because the tool is not centered. Back the tool out, stop the machine, and adjust the tool height before continuing to machine. There are additional tool holders in the cabinet that may be adjusted for other tools as well. Here are the steps for adjusting a tool's height. First, loosen the handle on the tool post. Then, clean the tool holder and post to remove any metal chips or flakes. Loosen the top nut while holding the lower knurled nut in place. Now, rotate the knurled nut to adjust the tool height to the correct setting. Turning clockwise brings the tool up, and turning counterclockwise brings the tool down. Check that your tool is centered. To do this correctly, put a thin piece of sheet metal between your stock and the tool, and gently run the tool into the stock. If the tool height is correctly set, the flat stock will be perfectly vertical as seen from the end of the lathe. If the flat stock leans towards you, the tool is too low. If it leans away from you, the tool is too high. Back the tool out and readjust the knurled nut if necessary. Now, hold the knurled nut and tighten the top nut down to lock it in place against the knurled nut. Recheck with a piece of sheet metal to make sure the tool position hasn't shifted with tightening. Finally, lift and drop the tool holder back into place, lock the tool post, and check again. Once this process is followed, the tool holder will be adjusted for that specific lathe and can be removed and replaced many times without further adjustment. As a reminder, it is always good practice to clean the surfaces of your tools before and after use to remove metal chips and flakes, as these can be larger than the dimension tolerance on many robot parts. On the collet lathe, the power will turn off when you bring the carriage too far to the left. You just need to bring the carriage back to the right past the head of the lathe and press the red power button to turn the power to the lathe back on. That does it for our second installment of the GRT lathe training video series. I hope this video has given you some insight into the tools used on the lathe as well as some general lathe information. If you have any questions, feel free to ask them during class so that everybody can learn the answers. Stay safe. I hope to see you all here soon.